Hello and welcome, and we're back at it again with another banger. And some of you have found the pattern right now when we're dividing exponents with common bases. All right, so let's take a look here. You should have expanded this already. Pause the video if you haven't done so already. What can you do here? What can you do here? Well, we know anything divided by itself is 1, so this will be 1, 1, 1, 1, 1, 1. What are you left with? Right? You're left with 3/5 to the second power. We have two factors up here. Do you think you know what the shortcut is? How could we have gotten this exponent of 2 just looking at this? That's right. You are going to, when you're dividing exponential expressions with common bases, you can subtract the exponents, right? Just like when we were multiplying with the product rule, this is what we call the quotient rule. The quotient rule, because we're dividing now, right? Let's take a look and expand number 6 and see if this is the same thing. Now, peep game here. I expanded this already, and we know that anything divided by itself, pause the video if you need to, pause the video to expand on your own before we go on, right? Is going to be 1, 1, 1, 1, 2, 3, 4, 5, 6. We are left with 6 bases of x, right? But peep this, right? I love math because you can always follow the order of operations. The numerator is a group in itself. Do we know how to do x to the 4th times x to the 5th? We know how to use the product rule there, right? What do you get in the numerator here? Well, we know when you're multiplying exponential expressions with common bases, you can add the exponent, so that's going to be x to the 9th over the denominator is not changing, right? And using that, look, do these things not match right here? Using the information that we know when you're dividing exponential expressions with common bases, you can subtract, your peep, right? Just use these patterns. Trust me, you guys can get this. Trust me. Now take a look at number 7. Now, this is very similar to a problem if I gave you this. Look, 5x to the 2nd times 4x to the 3rd. Y'all would know how to do that. But now we're just dividing here. Go ahead and expand this badge on, just to see what it's going to look like, though. Pause the video if you need to, though. All right. And I have 3 factors of m down here. This don't change nothing. See if you can try to do this on your own. I'm going to model it for you, right? Divide your numerals. 20 over 4, you can reduce that. 20 divided by 4, 4 divided by 4. Right? This is going to be 5 over 1. Come on now. Y'all know how to do this. All right? And this will give you 1, 1, 1. Y'all know how to do this. What's your final answer going to be? It's going to be 5m to the 2nd power. Why? 20 divided by 4 is 5. And we know what's the rule that we're learning, the quotient rule, when you're dividing, listen to the vocabulary, when you're dividing exponential expressions with common bases, you can subtract the exponents. Come on, y'all know how to do this. See if you can do this last one on your own before I go ahead and model it for us. Come on, y'all know how to do this, right? If you want to expand this, that's completely fine. If you think you know, I know how to do the rule already, that's fine too. Let me just show you the importance of learning this rule, because we don't want to do this every single time, right? I already wrote 4 A's down, 4 factors of A. Now I have to do B times B times B times B times B times B times B. 1, 2, 3, 4, 5, 6, 7. Right? This is a pain in the butt. Nobody wants to do this. A times what? What can you put here just to organize it, right? Times 1, it doesn't change the value. And then you have to do times B times B. How many B's in the denominator? 3. And then you can do times 1, just to line it up. Right? But you guys should know the pattern already, right? So if I just expanded it, but look if I use the pattern. That's a to the 4th minus what? 1. There's an exponent here, right? When you're dividing exponential expressions with common bases, you can subtract. That's right. It's going to be a to the 3rd. And then your b's, what's going to be your exponent for your b's? Is b to the 7th minus 3 is b to the, don't judge my 3, b to the 4th. So this should be a to the 3rd times b to the 4th. Or you could just put a 3 b to the 4th, right? A to the 3rd, b to the 4th. And if you were to do this here, look, a divided by a is 1. How many factors of a do you have in the numerator? 3. B divided by B divided by B, that's 1. And how many factors of B do you have in your numerator? 4. I know y'all see these patterns. Now, before you go to the next slide and do your vocabulary, I'm almost done with this lesson, I want you to peep this. Let's go back to example 3, example 4, real quick, right? What would you do here using your quotient rule? Because we expanded here. What would you do using your quotient rule? That's right. You would do y to the first minus 6. But what is 1 minus 6? This is y to the negative 5th power. You can have negative exponents. Yes, you can. But I want you to notice these are actually the exact same thing. Right? And we're going to learn about this tomorrow. So this is correct and this is correct. These are the exact same thing. Notice what happens when you have a negative exponent. What changes? What happened? Right? See if you can do this one here. If we use our exponent rule here, this is m to the third, n to the third minus what, 7? Then we n to the what, negative 4th power. Believe it or not, these two things are also the same. We're going to learn about negative exponents tomorrow. Right? We're going to learn about negative exponents tomorrow, but I just wanted to let you know, this is the quotient rule that we're learning today, right? Yes, you can have negative exponents, right? There's a little pattern notice here. You're not going to deal with too many negative exponents today. We'll dive into that tomorrow, but this is the pattern that we're learning. So you're going to go ahead and do some vocabulary, and then I'll check you later today.